Hello, this is Mariam Kassem, and this is my Lab 2 charge tapes revisited. So for our introduction, the purpose of this lab was, well, for Lab 1, we were supposed to find out how much excess charge is on one charge tape. And then for Lab 2, which is this one, we were supposed to model the experiment computationally where the charge is evenly distributed on the tape. Specifically, we were modeling one as a rod. The models and fundamentals for this lab is the use of F is equal to EQ, where E is the electric field, and F is equal to MA to calculate the charge. And then we would use E rod for a more approximate estimation. Our assumptions was that each U tape has the same net charge, and we were treating one tape as a single point charge and the other one as a rod. We were also assuming that there were no air resistance. For our preview of results, the tapes were positively charged, they repelled each other, and the charge per piece of tape was 1.8988 times 10 to the negative 8 coulombs. The physics principles, we use Coulomb's law, which is F is equal to KQ1, Q2 over R squared. We also use Newton's second law. And then lastly, the electric field for a rod with uniformly distributed charge. Surroundings, we have tape A and tape B for the system. The surroundings is Earth, and the initial conditions were two uncharged tapes, 0.2 meters each, were stuck to an uncharged tape on the desk and pulled off quickly to become charged. We observed that each tape was attracted to my hand and attracted to a negatively charged pen, so that means that the tapes were positively charged. In calculations, we have the length as 0.2 meters for the tape, the mass as 0.0002 kilograms, and the difference in height was 0.015 meters. We used the gravitational force and the electric force to find charge, which was 1.8988 e to the negative 8. For our Google script code, over here you can see the visual result. We got similar magnitudes for both the electric force and the gravitational force, which was a success. And then over here we had a method to find the current electric field. We used Coulomb's law, which was KQ1, Q2 for R squared, and we returned the value of the electric field. Over here, that was the mapping of the top tape and the bottom tape, which was the blue and the red line that you can see over here. We set the scale to 8e to the negative 7, and then we initialize the forces scales. And then we have a for loop over here to draw these little arrows, electric field arrows. We initialized them to 0, and then we calculated them by having another for loop to calculate the difference in electric fields, adding it to the current electric field, and then updating the force accordingly. We then drew the force arrows and the gravitational, like force arrows for the electrical and gravitational forces over here, and we changed the axes accordingly to our result. All the charge calculated produced the expected electric force, which balanced out the gravitational force as shown in the slide before. So for our sources of error, so tape B was a bit twisted, so the distance measured might not have been accurate. The charge isn't equal on both tapes. The charge on tape isn't uniform. And then lastly, the tape could have gone in contact with a neutral object and lost some of its charge. For our discussion, what if you had modeled each of your tapes as a single point charge, like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge. So for lab 1, which was the point charge model, we got 7 times 10 to the negative 9. And then for lab 2, we got 1.8988 times 10 to the negative 8 coulombs. So the lab 2 model had a greater charge than lab 1, so it was approximately 2.7 times larger than the point charge model. The estimates differ because lab 2 considers the charge being uniformly distributed rather than it being a single charge like lab 1. And lab 2 will also most likely be closer to the real value because a tape is closer to a rod than a point charge. Thank